All right, hey gang, Mr. Couples here. Just wanted to get right into the lesson today and not take up your time. So we're going to be talking about variables and expressions. Now, my hope is that you remember some things from last year with pre-algebra 1 as far as variables and expressions are concerned. But I've got a pretty cool activity here that I think is going to help to bring back some of those concepts that we covered last year, that you would have had covered last year. So I'm going to take my face off of here because I think that's kind of creepy. And we're going to focus in on the worksheet here that I gave you guys. So in starting off, it says here that to define an algebraic expression consists of sums and or products of numbers and variables, okay? Now, I don't think it defines what a variable is, but remember, a variable is anything that represents something else, okay? So a lot of times students will think a variable means x, which is very true, because x can represent anything, right? X could be the number of French fries that you ate the other night, or the number of gallons that you had to pump into your parents' car, okay? So yeah, X is a variable, A is a variable, B is a variable. Anything that represents something else is considered a variable. As far as a term, it says a term of any expression may be a number, a variable, and or the product or quotient. Now we're going to, a little remember here, product quotient, that quotient word I think some students or many students will forget. Product means to multiply. Quotient means to divide. So hopefully you remember those two terms from previous years. So we can either have a number, if it's a term, it's going to be a number, a variable, or to multiply a number in a variable, or to divide a number in a variable, okay? For example, we have 24 times m, okay? 24m is the same thing as 24 times m, plus 5n, 5 times n, plus 0.1, okay? All of this is considered a term. There are 3 terms here. Each one of these right here is its individual term, okay? So, yeah, just a review of what terms are. Now, here's the little example that we're going to kind of work through together. It says, write an algebraic expression. Explore. The Watkins family is designing a new path for their garden. They use black and white square tiles to make a pattern that they will use to build the path. Okay, so we've got the black tiles here, we've got the white tiles here, and you can see all of that. Complete the table. We're supposed to count, okay, for each stage. As the stage gets bigger and bigger, it becomes more and more complex, the number of white tiles. So with stage 1, we're counting that there are 2 white tiles, okay? For stage 1, the number of black tiles, there are 3 black tiles, okay? For a total of, if you count it up, we have, let's see here, 1, 2, oh, I miscounted there, sorry. We have actually 4 black tiles, don't we? Okay. So 1, 2, 3, 4. So for a total of, if we add those up, a total of 6. Okay. Now, right now, if you want to pause because you want to ignore Mr. Couples talking or you want to speed this up, that's fine with me, but we're just going to go ahead and fill in the rest of these stages here. So for stage 2, we have 4 white tiles and 5 black tiles for a total of 9. Okay. Stage 3, we have 6 black and 6 white for a total of 12. Okay. Now, if we were doing this in class, I'd ask you for observations. And I would like you to say, hey, as we increase the stage, initially, the number of white tiles was less than the number of black tiles. Great observation. But as we increase the stage, they've become equal, and if we were to make an estimation, we're probably going to say that the number of white tiles is going to exceed the number of black tiles, okay? So if you're a visual person, you may want to go ahead and do stage 4, okay? Now, as we look at this, stage 1 was a, let's see here, a 2 by 3. This was a 3 by 3. Now this is a 4 by 3. So stage 4 is going to actually be a 5 by 3. So if I do this, 1, 2, 3, 4, 5 by 3, our next stage will look something like this. Okay, and this outer rim in each stage is all black. So if I go into this, okay, so if we count these, the number of white tiles is going to be 2, 4, 6, 8 white tiles. And the number of black tiles is going to be 2, 4, 6, 7. Keep breaking my pencil here. So we have a total of 15 there. Okay? Now, I think you see patterns here forming, or at least I hope you do, and there's no need to continue to draw the pictures out. 2, 4, 6, 8. What's the next one? 10. Good. 4, 5, 6, 7. Next one? 8. Good. Okay? Now, from here, actually, I'm going to put the total down here. I'm going to have you guys add one more column, okay? And this is going to be stage N. Now, again, that's a variable. You could put X there, you could put Y there, it doesn't matter, okay? But the nth stage could represent any number, is what we want to fill in right here, okay? So, when you think about it, if I take this stage number, what can I do to that stage number to get this number right here? I hope that what you're seeing is if I take this stage number and double it, I get to that number right there. If I double this one, if I double this one, if I double this one, if I double this one. So I'm going to write this down. Okay, if I double that stage number, I get that next, the number of white tiles. Well, what can I do to the stage number to get this value right here? And what I can do here is this. For number 1 to get to 4, what I can do to number 2 to get to 5, what I can do to number 3 to get to 6, is I can add 3 to that one to get this one. I can add 3 to this one to get that one. I can add 3 to this one, and 3 to this one, and 3 to this one. So I'm going to write this down. If I add 3 to each of those, I get n plus 3. Now, if I bring those together, the sum goes right here. So if we take 2n plus n plus 3, think to yourself from last year, if we combine our like terms, what does that give us? Well, hopefully you're going to put down 3n plus 3. Okay? So now that we've got that column, we can answer the next couple situations here. It says for part B, suppose the Watkins family wants to make stage n of the pattern, which we already did. Write an expression for the number of white tiles that they need and explain how you wrote the expression. Okay? And you can put that down, and I'd like you to kind of revisit what I said a couple minutes ago and see if you can fill that out. Write how you wrote the expression. Okay? Explain. The next one, write an expression for the number of black tiles that they will need to make stage n for the pattern. The number of black tiles was n plus 3. Again, I'd like you to explain how we came up with that. Okay. For part D, it says write an expression for the total number of tiles they will need to make stage n of the pattern. Is there more than one way? Oh, I'm getting a little beyond myself, sorry. A little off the screen. Is there more than one way to write the expression and explain? Okay. So I'd actually like you to go ahead and fill that out. Now remember, this is the expression that we came up with right there. Is there another way to write that expression? Okay. See if you can think of something else that maybe I hadn't thought of. Okay. All right. Now, moving on to part E. If I can get that in my screen there. Fixing the camera. There you go. Okay. Looking at part E, it says this. Evaluate your expression in part D for n, for 1, 2, 3, 4, 5, to verify that it produces the same values as the bottom row of the table in part A. Okay? So what I can do here, remember our expression that we came up with was 3n plus 3, right? Okay? So if I go ahead and put that down, and plug in, I'm evaluating the expression where n is equal to 1. 3 times 1 is 3, plus 3, that's 6. Now, if you look back on the table before, that's what we got right there, okay? So that's a good thing, all right? If I do 3 and I'm going to do 2 now, evaluate the expression for 2, I get 6 plus 3. 3 times 2 is 6, plus 3, that's 9. Let's see, did we get the same thing here? Yes, we did, okay? So I'd like you to finish that one for me. Go ahead and do numbers 3, 4, and 5. Go ahead and figure out what those, make sure that those values are going to equal, and show the work there for those 3 right there, 3, 4, and 5, okay? Down here on the key concepts, I'm interested in if you remember these from last year. See if you can fill those out for me, okay? And I want to skip down to example number 2, all right? So in example number 2, we're going to start off with, it says the expression, so all this is an expression, remember these are all terms, 8x is a term, 12.5y is a term, and 6 is a term, but together it's an expression. Gives the total cost in dollars of ordering X t-shirts and Y caps from a website. The cost includes a fee for shipping that is the same no matter how many shirts or caps are ordered, okay? What does the coefficient, now coefficient means the number in front of the variable, okay? What does the number 8 represent in the expression? So up here, okay? Now remember, X t-shirts, okay? So keep that in mind, that's what we just read, X t-shirts. What does the term 8x represent, okay? So as I look at this, thoughts on what 8 means? Well, what I'm hoping that you're thinking is this, that 8 means this. It means how much each shirt cost, okay? So I'm going to put how much each shirt costs. $8. Okay, so we covered what the coefficient 8 represents. Now we need to talk about what does the 8 and the x represent? Well, if you think about it, if x is the number of t-shirts, okay, x is the number of t-shirts, and we put that with the 8, that means that if I go ahead and multiply 8 times the number of shirts I get, that gives me how much the entire cost of ordering all the t-shirts would be, okay? And so maybe I'll put it this way, what the purchase price would be to order the t-shirts. Okay? And so, you know, if you have 7 t-shirts, 8 times 7 is 56. Well, how much is it going to cost me to order the t-shirts? $56. Okay? So as we move on, part B, what does the coefficient 12.5 represent in the expression? I want you to think through that for me and consider what we did up here in A. And remember, Y is the number of caps that you're purchasing. Okay? So just keep that in mind as you work through B. So I'm going to put that as I want you guys to finish that out. Letter C, what is the fee for shipping? Which of those numbers would be the fee for shipping? Now, I have a hint for you, and that's this. The cost, I'm just going to read this last sentence here. The cost includes a fee for shipping that is the same no matter how many shirts or caps you order. Okay? Part D, how would you express the total cost in cost be different? Let me start over. How would the expression for the total cost be different if the company decides to increase the price of each shirt and cap by only $1.50? Explain. Okay? So just think through that process. I want you to do B, C, and D for me. Okay? All right, if you turn over to the next page, I'm going to have you put a big X across that. We're not going to worry about that one, okay? But I really want to summarize everything by having you guys look at 4, 5, and 6 here, okay? 7 and 8, you can ignore that. Don't even worry about that for me, and that's pretty much it. So have those problems done for me. Let's talk through this tomorrow, and let's see how we do. So have a good day, and we'll talk to you later.